Batten column. The batten shall be placed opposite to each other at each end of the member and at points where the member is stayed in its length, and as far as practicable be spaced and proportioned uniformly throughout. The number of battens shall be such that the member is divided into not less than 3 bays within its actual length from center to center of each end connection. These are the batten plates. And the slenderness ratio, effective slenderness ratio of the batten column is taken as 1.1 times the slenderness ratio of original, that is 10% increase. This is to account for shear deformation effects. Design specifications of battens. In that, first is thickness of batten or tie plate. The thickness of the batten should not be less than 1/50th of distance between innermost connecting lines of rivets or bolts or welds, whereas the spacing of the batten, let us say this is the spacing of the batten, say C, then C by R1, where R1 is minimum radius of gyration of channel section. This should not be more than 50 or it should not be more than 0.7 times KL by R effective of the batten column, where KL by R effective we already know it is 10% more, that is 1.1 times KL by R original. The spacing is fixed in this format, and then size of the batten, that is width of batten is equal to effective depth plus 2 times of end distance or edge distance. This is an intermediate batten, whereas this is an end batten, which can also be called as tie plate. In end batten, the effective depth DE is given as distance between CG of main members, that is, if this is a spacing S and CG distance is, let us say this is CY and this is also CY, then distance between CG, that is S plus 2 times of CY, is the effective depth in case of end battens, where effective depth is measured from end to end, center to center of the bolts. So this is effective depth in end batten, which is S plus 2y, whereas in intermediate battens effective depth should not be more than 3/4 of CG distance of main members, that is S plus 2 times of CY, and should not be less than 2 times of width of one main member. Let us say this width is B, then it should not be less than 2 times B. Whereas force in the batten system, battens are also designed for a transverse shear equal to 2.5% of the applied load P. So the lateral shear is Vt by 2n here and Vt by 2n here. The spacing is total C, then up to here it will be C by 2 and this is C by 2, and for the next C by 2 the transfer shear is Vt by 2n and Vt by 2n. Let us say the center to center spacing between the bolts is capital S, then this is capital S. Due to this Vt by 2n, there will be a moment or couple created which is equal to Vt by 2n into distance between the couple is C. So this way also there is a couple Vt by 2n into C created. Due to this couple, there will be reactions. Since the couple is anti-clockwise, there should be a clockwise set of reactions developing. That will be equal to the sum of both is Vt by n into C divided by this distance S will give us the reaction. So this is Vt by n into C divided by S. Drawing the shear force diagram is positive, right upwards is negative. So everywhere it will be positive, equal to a magnitude of Vtc by Sn, whereas the bending moment diagram, this way it will be negative and here it will be positive and equal to Vtc by 2n. So the batten should be designed for a shear force of Vb which is equal to Vtc by n into S and moment equal to Vtc by 2 into n. So batten shall be of plates, angles, channels or eye sections, and at either ends shall be riveted, bolted or welded to the main components so as to resist this Vb shear and M moment at each connection.